Yaskawa.
Good morning, everybody. Welcome to Yaskawa America's Training Cafe Express. Topic for today's webinar is modular machine commissioning with MPiec controllers. Here's a brief list of the topics that we will be covering today in today's webinar. How to design a project for use with a varying number of axes on your machine. What to expect when a controller that is configured with multiple axes is operated with part of the configuration missing. What is the recommended procedure for ensuring all servo pack or all drive parameters are retained in the IEC application's zipped project? And now I'd also like to today introduce a simplified procedure for replacing a drive in the field without special software. So generally, when a project is designed on the IEC platform, the machine builder configures all the axes in the hardware configuration. So all the axes that the machine is going to have would be configured in the hardware configuration, and that's saved in the configuration. The code is also designed such that all possible axes would be used in the code. Now, it is recommended that if the machine builder is shipping machines or different versions of the machine with varying number of axes counts in them, he or she includes a version number for each type of machine. For example, 0111 is a 3-axis machine version of a 4-axis machine whose version number is 1111. A 4-axis machine is 1111, and 0111 is a 3-axis machine version of that 4-axis machine, where the ones represent the axes that are being used or going to be used on that modular machine. So this could mean that you have axes 1, 2, and 3, and the 4th axis is missing in that particular version of that machine that was shipped out by the machine builder. Typically, once the code is completed, all the servo pack parameters are saved into the project, and the project is completed and the machine is shipped. There are two situations that generally come up when we talk or think about modular machines at a customer. First of all, let's say the customer does not use all the axes that are on the machine. The controller, when it powers up, does not find some of the configured axes during power up. So that is one scenario that can happen. The other scenario that can happen is, let's say he powers it up with a fewer number of axes, but then later on he decides that he wants to add a couple more axes that were initially configured but were not present on power up. Then he has to go through a certain number of steps to make sure that that newly added axis is usable on that machine. So basically, we're making the assumption here that the machine and the project have been configured with all possible configurations. All possible axes have been thought about, planned, and put into the project code and also in the configuration before it was shipped by the machine builder. So first case, if the configured axis is not found, or all configured axes or some of the axes are not found during startup. On power up, the customer or the machine operator can expect to encounter a controller alarm. And the controller alarm basically points to communication with a certain node that did not work because that particular axis was not powered on in that power cycle, in that particular power-up situation. Now, this particular controller alarm, remember this is not an access alarm, this is a controller alarm, can be read using the Y read alarm block, which is used to read any controller-related alarms. There is a parameter, there is a controller parameter, 1330, which gives the status of the drive if it is online. You can see here that 1330 can be now read using the MC read bool parameter function block. And if the axis is online, it basically comes up with a value of 1 at the output. The last output comes up with a value of 1. Remember, this is a Boolean output. and it can be read using the MC read bool parameter function block. Here you can see that in this particular example, the status of axis 4 is trying to be accessed, and you can see that axis 4 is not online. Now, any controller-related alarms that relate to an axis not being found or any other controller alarm can be cleared using the Y clear alarm block. So these are some of the building blocks that can be used to detect if an axis is online or the controller found an axis to be online, and if it did not and produce some kind of an alarm, these are some of the blocks that can be used to monitor the situation and get rid of any alarms so that the user can continue with the axes that are present on the machine at that point of time. Now let's move on to adding configured axes if axes are not found during startup. Let's say at startup the operator started off with 2 axes out of a 4-axis system, and later on desires to add on one more axis. Here are the steps that need to be done before that can be before the newly added axis can be used. Now, once a newly added axis is seen by the controller needs to synchronize the Mechatrolink communication network so that they can be resynchronized and all axes are resynchronized to the Mechatrolink clock. And to do that, the first step would be to ensure that all the Mechatrolink commands are disabled, which means it is desired that all the axes be disabled, and then the new axes be added onto the system, any alarms that exist in the system be cleared, and then Mechatrolink communication can be reset using the Y reset Mechatrolink function block. The Y reset Mechatrolink also does a soft reboot on all the drives present at that time to which the controller can communicate with. Once that is done, we also can basically validate whether the newly added axis is online, and that can be done using the or monitored using the parameter 1330 we mentioned earlier, using the MC read bool parameter function block. Let's go through a simple scenario which we can use to test all these steps and to see how all these steps can be used in a good manner, in a flowing manner, to ensure that all this switching of axes or adding axes or removing axes goes through in a smooth fashion. So let's say, for example, an OEM builds a machine with 4 axes, and the programmer puts in all the code that's required for 4 axes. And let's say a particular customer who buys this machine buys a 3-axis version of that 4-axis machine. Now this customer, when he takes it to his plant, can run the axes or run that machine in 3 different modes. The first one, where he can run it with all the 3 axes together. The second mode, he can run 2 axes at a time. There are 3 combinations of that. And the third option is to run 1 axis at a time. And he can also switch between these 3. So let's say at one point he starts with 2 axes at a time. He can either remove 1 axis or add the 3rd axis. He can go either up or down in the number of axes he wants while the machine is in operation, because he has the 3-axis version of that machine. So here's a quick line diagram of what you can expect, what the customer sees his 3-axis machine to be. Remember that the program in the controller that the OEM shipped is basically has the code that can control 4 axes in it. And this is just a 3-axis version of that 4-axis machine. So let's say we start off with all 3 axes together, axes 1, 2, and 3. Let's say the customer powers on with all the 3 axes connected. The first thing that will happen is the controller will come up looking for 4 axes, because that was a configuration that was shipped by the OEM. So it will look for all 4 axes, but won't find the 4th axis, and so there will be an alarm for the 4th axis. Here's an example of some code that can be written to ensure or to make sure that the startup procedure goes smooth. So we have a read alarm function block that reads the controller alarm at all times. And then in the first scan on power up, if the controller alarm is 23010008 or if the alarm is the Mechatrolink alarm that says it could not communicate with one particular axis, and that particular axis is the axis that was not configured for that particular version of the machine, for example, in this case, the 3-axis version, then we use a one-time clear alarm on power-up to clear that particular alarm. So in this case, when the customer is using a 3-axis machine and he's running a 4-axis code, when the controller powers up, it is going to complain that it did not find the 4th axis. So if that is the alarm that comes up, then we basically do a one-time clear alarm because we are expecting that alarm to come up. So a one-time clear alarm will basically clear that alarm in the first few scans itself. So this snippet is code that can help the customer in doing that. Once he gets past the clearing the alarm that says that the 4th axis was missing in his power-up sequence, the customer basically now has to make sure that he is telling the machine to use all the 3 axes that he wants. And here's a function block that Yaskawa built to manage multiple axes. So you can see here there are a few inputs in here. One of the inputs is a required configuration, and there are a few outputs that basically tell you the status of the configuration that is available. The first output that we are referring to there is a required axes ready output. It basically tells you if all the required axes that the customer wants to use are ready for use or not. And by ready for use, it means that if that particular axis is online and it is available for operation. There is also one output that basically tells the customer if a reset Mechatrolink command is required. And we'll see why that particular output might come on, or in what situations that particular output comes on. There's also an output for showing the user what axes are currently online, or what axes the controller sees as online, and also one which tells the user which ones are ready for operation. So in the first example that we were thinking about, where all the 3 axes were present on power on, you can see here that for axes online, you can see all the 3 axes were seen to be online, and all the 3 axes were seen to be ready for operation. All the user has to do now is to go in and put in the required configuration as an input. So once the user enters his required configuration, in this example he's using 3 axes, and he's using axes 1, 2, and 3, and he puts in the required configuration as an input, the axes ready output comes on, which means for his required configuration, all the axes are online and all the axes are ready for operation, and so he can basically use all the axes there, and then machine operation can start. Now let's say we take the operator has finished his shift, or he has now got to change a part. Let's say he wants to run it in a 2-axis mode, and he takes the 2nd axis offline. So now he has basically axes 1 and 3 that need to be run. Again, as soon as he unhooks axis 2, or he stops axis 2, you can see that the outputs, axes currently online and axes ready for operation, basically change, which means that, and you can also see that a reset Mechatrolink is required in this particular scenario. So it detected that an axis went offline, and it requires a reset Mechatrolink so that Mechatrolink can now be reset and resynchronized. So now the user basically goes ahead and changes the required axes input, where he makes the change such that only axes 1 and 3 are required, and he still has to reset Mechatrolink. And once Mechatrolink gets reset, you can see that the currently online axes output and the axes ready for operation match, which basically tell the operator that those 2 axes now are ready for operation. So this enables the operator to basically be able to use axes 1 and 3, even though 2 was now taken offline. And by offline, we do not mean unhooking the Mechatrolink network. We do not expect users to remove or add the Mechatrolink cable to take an axis offline. We're just referring to taking off power or e-stopping a particular axis. Remember, Mechatrolink has to be connected for any kind of communication. If one of the middle axes is the Mechatrolink cable is removed from one of the middle axes, it will basically cause disruption in communication, and none of the following axes would be able to operate. Now, moving on to a one-axis mode where the operator decides to use only axis 3. If axis 1 basically is taken offline, so you have axes 1 and 2 offline, and only axis 3 is in operation. On the modular axis manager, which we'll take a look into later, you basically can see here that, again, once that axis is removed, there is the output which tells the operator that a reset of Mechatrolink is required, and that one more axis has gone online. On changing the required axis input to 100, which means only axis 3 is going to be used in the next operations, and on issuing a reset Mechatrolink, we basically can see that the currently online axis output and axis ready for operation output now match, and also the required axis ready output comes on, which means the user is now ready, or the machine is now ready for operation with just axis 3. Now let's say after that shift is done, if the customer wants to go back to using all 3 axes, he puts axes 1 and 2 back online. You can see the output from axes currently online that basically goes up to all 3 axes now. It also tells you that a reset of Mechatrolink is required to resynchronize Mechatrolink, and the user has to now change his required axis input to 0, 1, 1, 1 to use all 3 axes, and after issuing a reset Mechatrolink, all 3 axes now are online and ready for use, and we basically have the required axis ready output, which tells us the operator that now he's ready to go. So we'll take a quick pause here to look at any questions that have come up.
Nishant, there's one question about the axis ready for operation output. Does that update live, or does it need to see a change in one of the inputs of the function block to reflect a change in the status?
Okay, so the question was whether the required axis ready output comes up as a live output or not, or does it require some toggling of input bits. It is, as you can see, this function block that was built is basically built on the PLC open standard, which means that if you have if that function block is being run off an enable input, it basically, if that enable is held high, it will show the live status of what's happening. So it does not have to be toggled. There is no execute bit to toggle and show live status. This bit, as long as the enable bit is true, it is going to show the live status of your machine. There's another question about why valid is off in the second Axis Manager function block there. When reset Mechatrolink is being executed, the status of the axes that are online may not be true, or may not, the status of parameter 1330 may not be true while reset Mechatrolink is being done, because reset Mechatrolink is basically soft rebooting all the drives that are on the network, and so the status may not be true. So we do not want the function block to be showing a valid output, because the outputs there may not be valid while reset Mechatrolink is being run inside the function block. And once the Mechatrolink reset is done, the valid comes back on, and all the outputs of that function block now get turned on. So that particular time period where reset Mechatrolink is executing, the valid output on that function block turns off. And it turns off so that users do not tap into any one of these outputs and start using it for monitoring or any such purposes. So while reset Mechatrolink is executing, the valid can turn off, or does turn off.
Okay, so the user should OR the valid output with the comparison for the axes ready to be sure.
Yes, they should basically OR the valid with the required axis ready output.
Okay, thanks, Nishant. There's a couple more questions maybe we can address right now. And another one asks if this procedure works if the machine is powered down and the Mechatronic cables are rewired such that the machine is now missing one of the axes completely.
Yes, yes. This will basically take effect even if the Mechatronic cables are rearranged and some of the axes are missing in that case, because as long as the node numbers are the same, it does not matter how the Mechatronic axes are, or how the Mechatronic cables are arranged or rearranged, because the controller basically is looking for particular nodes and not the configuration of the Mechatronic cables. So this will work in that case also. Any further questions? If not, I'd like to take a quick peek at this Modular Access Manager function block. Here's this the function block that was built particularly for this purpose. You can see here. You can see here the function block, and this is the internal of, this is the inside of the function block, where you can see that I have a 3-axis system on a 4-axis configuration, or 4-axis configured program. You can see here controller parameter 1330 is being read at all times, and it does show that axis 4 is not available. And anytime or the ready for operation status is basically deciphered from this particular these particular lines of code here on power up, and after a reset Mechatronic is done, we basically come up and decide if an axis is ready for operation. And if the current status and ready for operation are not the same, then basically a reset Mechatronic is requested. And once a reset Mechatronic has been commanded from the user, it goes in and executes the reset Mechatronic function block. And once Mechatronic reset Mechatronic function block executes, some controller alarms regarding temporary loss of communication to the servo pack do come up, and those can be cleared using clear alarms. And after the clear alarms are done, we also do MC reset on all the axes, such that any after the Mechatronic reset is done, any prevailing alarms or axes or controller alarms are taken care of. And once that's done, we make a decision if the axis is ready. And the axes are ready if the required axes are online, if they're ready for operation, and if they're alarm free. So at the end of the Mechatronic reset function, if there are some alarms on the axes, then the ready for operation will not come on. So you can see here that all 3 of these conditions have to be true. The axis must be online, they must be ready for operation, and they must be alarm free for that particular output bit on the axis or Modular Access Manager function block to come on. And this function block has been written in with the spirit of the PLC Open function block, such that it does have outputs like valid, error, active, error ID, etc. So there was a question in between whether this particular function block has been made part of any toolbox, and not yet. We are still in testing phases. We'd like to take some of the comments and inputs from all of you today, and your questions from all of you today, such that we can basically implement this in any one of the toolboxes that you commonly use. So we'd like to look at some questions, some scenarios in today's webinar, and test it out so that it can be a robust function block once it's released. So yes, definitely this will be, we do plan to keep it or incorporate this into any one of the toolboxes. And this is not going to be a locked function block, so you can, the users basically can go in and change the configuration. This has been built with just 4 axes in mind, and you can see here that you have up to 16 axes that can be controlled or configured using this this particular function block. Okay, I'd like to show you an example here where one of the axes was basically taken offline. You can see here that axis 1 in this case was taken offline, which means now the controller sees only axes 2 and 3 from this particular output here. Axis currently online, it sees axes only axes 2 and 3 online, whereas the user had powered on the machine with axes 1, 2, and 3. So let's say the operator now wants to use only axes 2 and 3. It says that a reset mechatrolink is required. Once we go ahead and do the mechatrolink reset, you can see that the valid output goes off while the mechatrolink reset is being done. And while the mechatrolink reset is being done, the axis online status shows 0. Once the mechatrolink reset is done and the output is valid, you can see that the required axis becomes ready for use. And you can see here that the user's required axes is the same as the number of axes online, and those 2 axes are ready for operation. This basically forces required axis ready output to also come on, and now the user can basically go ahead and use those 2 axes and run the machine with those 2 axes. So that was just a quick example, quick demonstration, live demonstration of what happens if a particular axis is removed from operation. And the same is also true if an axis, if basically the third axis gets added on to it, or in this case, if the first axis gets added on while the machine is in a standstill state. So moving on, I'd like to talk about having access and controlling the drive parameters from MotionWorks IEC and saving the latest and the best drive parameters for a particular machine using MotionWorks IEC as a project and saving it in the MotionWorks IEC project. First step would be to save the latest drive parameters using hardware configuration, because typically in machine building, once the code is written and once the code is tested, operators or programmers and startup engineers basically go through the process of tuning the servos. And once the tuning is done and the users are happy with their tuning performance, the parameters then need to be saved from the servo packs themselves into the project. And this can be done by going online and saving using the hardware configuration. Just remember to save or use the startup configuration during this process. Once these parameters are saved, they're also saved on the controller. They're not just saved in the project, they're also saved in the controller's memory. And this can be validated and verified using the project archive page in the web server of the IEC controller. You can see here at the very bottom, for the 4-axis machine, all the 4 parameter files are saved in the controller as well. Let me, this particular function blocks, or a couple of function blocks, have been in the in MotionWorks IEC for some time now, but I'd just like to refresh everybody's memory and about why this is important and how this can be used in a project. Y verify parameters can be used to compare the drive parameters on the controller with the drive parameters on the drive itself. When this function block is executed, it compares each parameter as the controller thinks it is with each parameter, with each corresponding parameter on the drive. And if all the parameters match, basically the matches output on this particular function block becomes true. If there is a mismatch in any one parameter, that the first parameter that does not match between the controller side setting and the drive side setting is shown under invalid parameter. And it also shows the expected, or the parameter that the controller thinks it should be, and what's actual in the drive. So this basically tells you and lets the operator or lets the user decide which parameter is good and which, if the parameter needs to be overwritten or if the parameter needs to be kept. But it basically gives you a list of, basically points you towards the first parameter that does not match between the controller and the drive. Once a decision on which set of parameter needs to be kept is made, the user can use a write parameters function block to write the controller side parameters into the drive. And this particular write parameters and these two function blocks, verify parameters and write parameters function blocks, are used when drives need to be replaced on the field, and this is also part of a modular machine setup. I'd like to introduce everybody to a new feature on the web server of the IEC controller. It is available in the project archive page for all controllers that have controller firmware version 2.2 and higher. On the project archive page, users will now see a particular drive parameter link, which basically lets them access and write drive parameters into the drive using the controller's web server. So you do not need any code in your software for using this parameter. So basically, you can access or you can basically write into the drive from the web server if you have the XML file saved in the controller's memory. And you can see here, once you click on that drive parameters link on the web server's project archive, it takes you to the drive parameters page, which also tells you which axes are connected and which are not, and also lets you verify between parameters on the controller and on the drive, and lets you write from the controller into the drive. And this again can be used when drives are replaced in the field. You can see if you click on write, it writes the controller side drive parameters into the drive, and if the verify button can be used to verify controller side drive parameters with the ones on the drive. Once again, to recap, this is a feature that's available for users or machine operators to transfer or helps users in replacing drives in the field. And even if it's not coded in the project itself or coded in the program to use write drive parameters as a function block, the operator could basically go to the web server and write the controller's saved parameters into the drive, into a new drive if a drive has been replaced. And this is available in IEC controllers with firmware version 2.2 and higher. 2.2 is available on the web, and we recommend all users to upgrade to 2.2 as much as possible. That brings us to the end of today's webinar. Let's just open up the session for any more questions that we have here. I'll try to answer as many as possible.
There's a question concerning if we can recommend any best practices for determining if an amplifier has been replaced with a new one.
Yes, there is. If a new amplifier has been put up in a machine, we could always use one of the function blocks that we talked about here. Why verify parameters? It basically does a check of parameters that were stored on the controller relating to a particular axis, and the one that and the parameters on the axes that are connected to it at that point in time. So if there is a new amplifier in place of an older one which was running, Y-verify parameters will definitely look up and find the differences in parameters. Newly installed amplifiers will definitely have default parameters or parameters that have not been changed at all. And in that case, the difference will be detected by Y-verify parameters and would alert the user that a new amp, and this would alert the user that a new amp is in place. And basically you could use the right parameters to, right drive parameters to send the existing parameter, saved parameter file to the drive.
Yes, and some users have written code to detect that the amplifier is new or out of the box. Sometimes, if they're changing amplifier parameters via the program, then the verify parameters isn't as reliable in those cases. So, a good test is checking for PN20E to not be equal to 1, which is a forced parameter by the hardware configuration, and it's not the same as the out-of-the-box default, which has a value of 4. So that's a good reference parameter to check. It's been changed, and then to invoke the right drive parameters to replace the drive parameters in that case.
Yep, the electronic gear ratio parameter 20E out of the box, and the default out of the box is 4, and for a configured servo pack it is 1 because it's forced by the hardware configuration. That could be a potential parameter that can be checked to see if it's a default or not.
There was a question earlier on that I think we did answer, but it's worth repeating the description because there was a lot of people that joined the webinar a little bit later than the actual start, and the question was concerning the modular configuration. And it's in regards to physically disconnecting devices from the network. And does the controller still operate in that situation? And the answer is yes. That's kind of one of the main design points we are discussing in the webinar, is that the concept is to basically program the machine for the maximum configuration that the equipment will require, and then to programmatically ignore alarms for axes that are not intended in a certain situation. So there's a question about why read parameters to overwrite the XML file is stored on the controller, and there's not the ability to upload from the amplifiers and have it stored on the controller without using the hardware configuration software to do that. So that means that if Signal Win or some other handheld operator were used to change servo pack parameters, there's no way to get those changed parameters back into the controller's archive files without the hardware configuration. And of course, you could do that manually by singling out the parameters you're changing and read those parameters and store those as an IEC variable and write them back at some future point. But that's more tedious if you try to replicate the entire parameter list. That is probably something we could think about adding to the web server in the future. And finally, there's a question about the ability to change the gear ratio parameter in the servo pack from the IEC code. And that's it's possible in certain circumstances that'll work fine. Referring back to the same gear ratio parameters we mentioned earlier as a forced default, the PN20E, I believe, and the other one is it 210?
210.
Are typically forced to a known value so that the other user unit scale factors involved are correct. But for applications where there is a physical gear ratio change possible in the machine, it is possible to change those PNs to accommodate for that different gear ratio. And the user units in the controller will be the same for the same travel distance. And you just have to be aware that the hardware configuration, if ever used after that point, will always force those values back to the value of 1 every time you hit save while you're online. But of course, you can always go behind that and override that with the IEC application if necessary.
If you have any further questions, please do email it to training@yaskawa.com, and or you can include it in the survey that will be sent out to all of you users, all of you who attended the webinar today. So if you do have questions, please contact us. This presentation will be placed on the web. It will be modified just a little bit, just so that we try to answer some of these questions that came up today, and it will be placed on the web, and please do look out for it. If you need a copy immediately, please you can contact me over email, and I'd be happy to email it to you. But this will be available for future reference and for future use, and we will try to incorporate that particular function block into a toolbox for use.
Okay, Nishant, thanks very much.
Thank you all for joining, and hope you have a good day.